started, and we'll see if anyone else and that manages to show up. So, good morning, everyone.
Good morning.
My name is Mark Murphy, and I'm here to talk to you about securing your Android applications. Most of you hopefully have done some Android development before, and that if you haven't, some of the
Sorry, wrong one.
was that something I said?
No. Sorry. He hasn't done it yet, but
Anyway, unfortunately, that significantly reduced the size of my audience by a noteworthy percentage. So anyway, I mean, if you haven't done Android development, and then many of the concepts that I'll talk about here and that will be applicable to other environments in one form or fashion, and that though some of the technical implementations that I'll talk about may somewhat flit past your head, so it should be useful for all of you. The degree of usefulness, and that is certainly going to vary. A couple of administrivia things, and that if you could take your phones and put them on vibrate or silent or forward them to 10 Downing Street or whatever you normally do when you don't want to be disturbed, that'd be awesome. If you have questions anywhere along the way, just let me know, and that don't feel you have to wait till the end. And that this is being recorded, I presume. I've got a little red light showing at me. Hi, camera. So also bear that in mind if you do decide to, escape somewhere along the line. Also, and that you are all given thumb drives, which have a presentation on them that vaguely resembles the one that I'm going to be showing you here. But they asked for that presentation deck a couple weeks ago, and I was editing these slides yesterday. And that there is going to be a QR code in the short URL at the end for you to be able to download the actual slides that I'm going to be using here, which are both new and improved. But we're here today to talk about defending your users against the forces of evil. And that some of the stuff that I'm going to talk about here will have other utility, and that you're worried about, you've got multimedia assets and that you want to protect using some sort of DRM-ish algorithm, or things along those lines. Some of what I'll talk about here will have some relevance there, but that's not really the point. I'm worried about our users because our users are awash in a sea of evil. And that whether it is lighter weight things like your garden variety script kitties, and that up to more serious concerns, some of which change over time. For example, I mean, there was just an article in Australia's The Age, and that just the past few days, and that talking about how spyware is increasingly being used, in domestic violence and other sorts of situations where people are downloading nanny cams and the track your children sorts of apps and that. And while the use of those apps for those specific use cases is reasonable, using that to track your ex, stalk, the celebrity, that sort of stuff, and that starts becoming much more disturbing. And of course, a lot of people in that are going to be thinking about that last bullet, state actors. You're probably thinking that I'm thinking about, a particular group of 5 state actors, and that who've been in the news over the past year or so, and that for wide-scale surveillance and so forth. They are certainly state actors to pay attention to and keep tabs on what it is that's being disclosed that they are doing. But there are other state actors, and that beyond those 5. Even if you think that those 5 and that are righteous and just in what they're doing, the notion that there are other state actors who you may not like nearly so much that are also doing those same sorts of things. Even if they can't necessarily do it on an international basis, they can certainly do it within their own borders. Just within the past few months, and that we've had the whole Turkey banning of Twitter and whatnot, and blocking things left and right. It's a short hop from there to being able to more surveil and try to use those sorts of things to figure out, okay, well, these are particular dissidents, and that we are going to pressure, and that because they're not as high profile, we want to shut them up. in the Ukraine, and that earlier this year there was that handy little text message that went out to lots of people saying, hi, your cell phone was seen in the vicinity of a protest the other day. Have a nice day. And it is a very short step from there for that turning around and being used and that for rounding up people en masse. And so now, if you're writing the next Flappy Bird clone, and that you probably aren't going to be panicking about this stuff quite so much, and that unless you're here to save the birds, but there are going to be any number of apps where we need to think long and hard about, how are we making sure that the user's data is the user's data and stays the user's data and doesn't become the user's and in other parties' data. That we are ensuring that their data isn't sniffed in transit, it isn't absconded with off their devices, it isn't, and then modified. And that go in and tinker with that data in ways that might negatively affect the user, such as, oh hey, we're going to go in and we're going to load a bunch of child porn onto this person's phone and then turn around and arrest them for having child porn in order to be able to set them up for a fall. The problem is that doing the security stuff is oftentimes not that easy. That QR code leads to a white paper published last year. A bunch of academic researchers created a tool called CryptoLint. Lint, as you're aware, and that is looking at a code base and saying, okay, what have you done that is technically legal from a compilation standpoint, but probably not what you want? CryptoLint is focused specifically on common flaws in cryptography, such as hard-coding the password, They analyzed nearly 12,000 Android applications and found that 88% of them were screwing up in one form or fashion in things that CryptoLint was able to detect. So look to the person to your left, look to the person to your right, 2/3% chance that all three of you have screwed up something, and that with security. And so what my goal here is today is to basically try to point out different areas and that you should be thinking about. Where possible, show you easy ways of dealing with those things that you should be thinking about so that you can do a better job and that of securing your users. If there is one thing you take away from this presentation, please use SSL. Just do it. In part because normally it just works. If you've got your web server set up, you stick the little S and that at the end of your scheme, and then poof, magic crypto happens. The problems come in and that where it's not quite that straightforward. For example, you want to have a test server somewhere, and you've got some sort of a self-signed SSL certificate for that test server. Well, self-signed certificates are going to fail out of the box, and so you need to go in and do a little bit of work in order to be able to arrange to support those self-signed certificates. Your organization may be big enough that you have your own private certificate authority, and that you're not necessarily using certs that are backed by some common root certificate authority, your VeriSigns and whatnot of the world, but instead is backed to your organization, principally for internal use apps and things like that, your intranets and so forth. Well, those certificates aren't going to be valid, determined as valid, because the Java/Android code is going to try validating all these certificates, and it's going to come to the end, and it's going to say, but I don't recognize any of that stuff. And it's going to fail. And so you've got to do stuff with custom trust managers in order to be able to teach Android that no, if for my app, these scenarios are fine. The problem is that too many developers go to Stack Overflow. And they look up, hey, how do I deal with self-signed certificates? And they see the answers out there that say, oh yeah, you create that trust manager that just accepts everything. And we completely ignore the incoming certificates and say, yeah, everything's fine. Because it's really easy to write one of those. It's like, maybe 10 lines of code if there's line wrapping and that going on. But you've got to be really careful with that. Just in this past week, the U.S. Federal Trade Commission has filed suit against Fandango and Credit Karma, and that specifically for doing this, that they shipped apps in production that totally ignore the incoming certificates, that they do SSL, but they've wired up a trust manager that said, yeah, whatever, we'll accept anything. And so the FTC is saying, you know, that's not good, and that you could have problems there. And it is going to be a short step from there for, you know, the FTC equivalent here in the UK or other countries, and that to start doing the same thing. Now, they're going to tend to go after bigger brands first. Whether or not you're associated with a bigger brand, I can't say. But the do not ship in production code that has a totally brain dead trust manager where you say, yep, if it's a certificate, it must be good. And that because nobody out there would do anything that would be otherwise.
Wow. Is there any like minimum level recommended, like 128 out of 56 KB encryption level or something like that?
Bigger is better. And that from an Android standpoint, that would be no different than really your web server recommendations, and so whatever the current recommended model would be for, you know, serving up to a web browser will be fine for Android, and that the I don't have all of the numbers memorized, and that I go and look them up when I need to generate a cert. But if it's good for the web, it should be fine for your cases. And in some cases, there's things that you can do that's better. To try to help make managing this stuff in Android apps a bit easier, I've been adding some code to my Quack security library. I actually didn't do an introduction earlier on, but in case you don't know me, I wrote the Busy Coder's Guide to Android Development, the first, oldest, and most up-to-date book on Android development. I've also answered 12,000 or so Stack Overflow questions, and I've published a number of the Commons Ware Android components, and that's the Quack libraries. Quack Security is one that is, not surprisingly, focused on security-related issues. One of the things I've added in there is a trust manager builder, a fluent interface for you to be able to create custom trust managers to handle certain scenarios that are reasonably common yet clunky to set up necessarily on your own in Java, so that you can then turn around and use those custom trust managers with HTTPS URL connection, OK HTTP, HTTP client if you're still using it, those sorts of things to be able to configure your SSL better. So you wind up with code a little bit like this. I can set up a trust manager builder that says, what I want to do is I want to check for a self-signed certificate. I've loaded in as a raw resource a certificate I want to compare against. Here is the passcode for that certificate store, and that here hard-coded, because usually these aren't going to come from a user, and that if they are, I accept a char array rather than a string, so you get an easier time of wiping out that password from memory if you want. So if we will accept either this self-signed certificate or anything that the default trust managers will do. And so the standard Android behavior, and that all of the root CAs and that it supports will take care of that too. So that way I can maybe use this set of custom trust managers and so forth, and that for a variety of operations, not only talking to my own back-end web service that I'm using a self-signed certificate for, but also maybe my production app. And then you turn around and you create an SSL context, open up your connection, whether it's HTTPS URL connection, OK HTTP or whatever, and then you tell that context, hey, please use this array of trust managers that builder is building, and use that SSL socket factory that we get from this context for this connection, and then that connection is going to use these rules for determining whether or not the SSL is valid or not. Now, I've got other options in here, in that if you want to specifically accept a particular private certificate authority, there's hooks in there for that, and I'm going to be adding other stuff over time. So just because you're trying to use some self-signed certificate, you don't have to go in and implement the blind do, accept all, trust manager, and that there are ways, whether you do it yourself, use a library like this, that you can teach Android relatively easily. Hey, feel free to use this self-signed certificate, and then it will validate against your test servers, staging servers, or as we'll talk about in a little bit, even possibly your production servers that are using a self-signed server. What we're really worried about with the certificate validation are the so-called man-in-the-middle attacks. And that, though you're welcome to substitute other values for that first N, and that if you don't want to be considered sexist, and that if you are worried about being considered speciesist and Martian in the middle might be a concern, feel free to go with Murphy in the middle, and that I'll take the blame. And we're worried about somebody being able to sniff on these connections because they spoof the certificates. That they have intercepted things at the Wi-Fi access point or somewhere else along the chain between client and server, where they've got a proxy that goes in there. We wind up talking to the proxy. The proxy sends us certificates back that claim to be, for this particular connection, even though they're fraudulent, and that if we blindly accept those certificates, well, then we're going to have decrypted data at that proxy, and that proxy therefore could be doing stuff with that data that our users would prefer that they don't do. One particular flavor of this problem comes with the hacked certificate authority. Certificate authorities, you would think, would have buku security for making sure that nobody can go in and create fake certificates and that claim to be processed by that certificate authority. Komodo, DigiNotar, Turk Trust, and others have demonstrated amply that certificate authorities and that have the same security problems that everybody else does. And there have been cases where there have been fake Google certificates that have been floating around the internet saying that yes, I am claiming to be doing an SSL connection for something at google.com, where it's not an actual certificate that Google created, that it was forged based upon a hacked certificate authority. One solution for dealing with this is to do what you would never think of doing in ordinary web development, which is to use a self-signed certificate. Self-signed certificates and that have, a negative reputation in the web because web browsers, don't like them, and with good reason. But the whole point behind the certificate authority is really to be handling scenarios like web browsers and web servers, where we have in web browser manufacturers and in websites. We don't know up front what websites a given web browser is going to talk to, and therefore the certificate authority mechanism is some way of validating that, yeah, okay, this is all, fine, and that is a reasonable solution. But if you've got an Android app that is talking to your web service, that's one-to-one. We don't need to worry about a certificate authority. Just use a self-signed certificate. And that particularly if that web service is solely in support of a mobile app, maybe beyond Android, maybe you're doing your iOS and whatnot and that with it as well, but where you don't need web browsers hitting that particular web service, use a self-signed certificate. You can then validate on the client, is it this actual exact certificate? And it doesn't matter whether there's a hacked CA floating around, you're not using the certificate authorities in the first place. But sometimes that's not going to fly, particularly in the case where that same server is also handling web requests, and that whether it be a traditional website, web services to be consumed by AJAX code on the web app, things along those lines, self-signed certificates aren't going to work well there. There are other things that you can do though. Certificate pinning basically says, okay, well, if we can't confirm an individual certificate, can we at least validate that it's from a certificate authority that we're supposed to be working with? We buy our certificates always from VeriSign. If somebody else is trying to communicate with our app and its SSL certificates are from some other certificate authority, clearly that ain't us. And therefore that particular certificate must be fraudulent. Moxie Marlinspike, nom de plume of a popular security researcher, has the Android pinning project. This is a custom trust manager that implements this sort of a pinning mechanism. It uses the same pin structure as is used by Google Chrome. Chrome pins very popular domains, such as google.com, to pick one at random. And that browser knows rules about all the google.com SSL certificates. It knows that there are these 4 CAs that Google uses. If it sees certificates from any other certificate authority, must be bad. And there is a particular structure, a particular hash of the subject public key info, and that Google Chrome uses. Moxie's code uses that same structure for being able to implement pinning in a custom trust manager in Android. The downside of this code is it's GPL v3 licensed, and that which may cause problems for you in various application settings due to license concerns. I'm going to try to convince him to relicense it, and I may wind up writing my own if I can't, while trying very, very hard not to get into any infringement issues, because we could really use a pinning solution in that, and I can understand philosophically why he may want GPL-v3 in that, but I mean, yeah, it's gonna present problems for a lot of organizations, and therefore is something to watch out for. Another thing that you can do to help deal with man-in-the-middle attacks is certificate memorization. Maybe you don't know what the certificate authority necessarily is going to be. You can't strictly pin to that. You don't trust that, purchasing might decide to buy from some other CA because they've got $10 off, or something along those lines. But what you do know is that when you're changing your certificates, you know that you rotate your certificates on an annual basis, and it's going to happen every April 2nd, or whatever. Certificate memorization basically says, all right, let's go with a trust on first use model. We'll assume, since statistically speaking it's unlikely that somebody's going to be hacked, we're going to assume that the certificate that they first see is valid. But then we're going to yelp if we see a different certificate. And so, 2 months from now, all of a sudden we do a connection, we get a different certificate than what the user originally did. We've got no indication anywhere that we actually changed our certificate. The app and that can then tell the user, hey, we're seeing something different. Is this something that you are expecting? And therefore is, you were told by IT, yes, you're going to get this pop-up dialogue and that warning you about this stuff, just say okay. Or if you're unaware of anything like that, you may be the victim of a man-in-the-middle attack, and that please you may want to discontinue your use of the application. There is a Memorizing Trust Manager implementation available out on the interwebs as well. This one MIT license, so license issues aren't there. I'm not a big fan of the implementation and that under the covers, and that it does some kind of squirrely Android things. The security is probably fine, and from an Android standpoint, it does stuff that I'm not real happy with. And so this is another thing that I will probably be re-implementing here, and that and be including in my Quack security library, a memorization solution, and that is a bit more, gives you more control, and that they assume that they can handle all the UI for validating that certificate, which I know won't fly because the graphic designers are going to want to get involved, and so having a sample implementation with the hooks for you to be able to provide your own UI for that stuff is going to be important for adoption. By the way, all my Quack libraries are Apache 2 licensed, and so long as you don't sue me for patent infringement, you can do anything you want with that code. I really wanted to do what part of encrypting all the things you not understand, but that was getting the font a little small in the image. And that beyond encrypting data in motion, you also need to think a little bit about encrypting the data at rest. And that because Android devices, if they fall into the hands of the forces of evil, the forces of evil are going to be able to get at storage, even internal storage. We think of internal storage as being private to our app, but then, pretty much every device out there, there's some recipe for rooting it, if not permanently, at least on a temporary basis. And all the forces of evil need is temporary access, and that in order to be able to slurp down the data. They don't care about surviving a reboot, so long as they can keep the phone juiced up, and they've got root access. They can do their work as in whatever time they need. There's a couple of ways of approaching the problem. One is to worry about the encryption yourself. Once again, this is a case where doing the right thing is sometimes complicated. There are, that crypto-lint, a lot of the things that it's checking for are things like, insufficient key derivation iterations and stuff like that, which to a lot of developers is, what the heck is a key derivation, and how many iterations do I need, and so forth. And so ideally, you try to aim for libraries that do the right thing out of the box, but then maybe customizable beyond that if you have particular requirements. Your IT department has got a bee in its bonnet about particular encryption algorithms and therefore wants to go and have you use something other than the defaults. My go-to solution for internal storage encrypting that, if it's a database, is SQL Cipher for Android. This is a near drop-in replacement for SQLite. You download a zip file, unpack some jars, Linux SOs, and an asset, put those in your project, change your import statements from being android.database and android.database.SQLite to their SQL Cipher for Android equivalents. Supply a passphrase in your get readable and get writable database calls on your SQLite Open Helper or the equivalent sorts of static methods on the SQLite database class, and you're done. Everything else is identical. It's all the same query, raw query, insert, update, delete, exec SQL stuff that you've been doing. You get the same cursors back that you've been doing, that you can pop them into your cursor adapters or whatever it is you want to do with them. And it transparently is going to provide AES 256 encryption on the fly, and that of all your contents, including your table schemas, all the metadata and whatnot. The downside is it does add some bulk. And that the way they implement this is that they ship a complete copy of SQLite that's got the SQL Cipher extensions baked into it. They've got no way of really grafting that into the firmware copy on the device. And because OpenSSL has changed over the years and there's been bug fixes that they haven't made it out to all Android devices because not every manufacturer updates their devices. They ship their own copy of OpenSSL, and so it's going to add several megabytes to your application size. Some circumstances that's going to be a huge barrier to adoption, particularly if you are already hitting up against limits like, say, the 50 megabyte Play Store limit. In other circumstances, a few megs here, a few megs there, big deal.
How do you protect the password?
Well, that kind of depends on what you're trying to do. In the ideal circumstance, you don't do what I'm going to show you. And I've got a sample app in my book that, let's see here, it is in my provider, and that where I am working with SQL Cipher, and so my imports are for net.sqlcipher.database.SQLite database and net.sqlcipher.database.SQLite query builder. Again, their APIs are the same, other than when you're opening up the database, you got to provide a passphrase, which in my case, actually this is not as bad as it could be, at least it looks better, and that I am having this passed into my content provider via the call mechanism. Call's a little known corner of the content provider API, added an API level 11. It basically allows you to do kind of almost bound service style remote procedure calls with a content provider. You basically provide a method name and a bundle of data that then comes into the call method, and it's up to it to look at that method and say, oh, well, you wanted to perform this operation here's the data to work with, and here's a bundle of return values. And that, not necessarily having to do anything with a particular database operation, useful for configuration purposes. And in my case, I am using call in order to say, hey, here's the passphrase that should be used when I'm working with this content provider. In theory, that should come from the user. I should be popping up a dialog, having a fragment, whatever, and that where I'm collecting the passphrase from the user. This particular sample, I am, well, I'm kind of hard coding it. And that, which is not good. And that just because we do things in a book example does not necessarily mean it's the best thing in the world. And that and if you actually get the book rather than just downloading the source code to the samples, and that you'll actually see paragraphs explaining, yeah, don't do this. We're doing this for simplicity. Here's another example later on that does a better job. And that ideally the passwords are coming from the user. These passwords, though, are going to go through, I think in the current version of SQL Cypher, 64,000 iterations of PBKTF2. And that in other words, that value, secret, is going to be hashed 64,000 times. And it's that resulting hashed value that is actually the key for the encryption that's being used in the database. And that's to help defend against dictionary attacks. That either, if they're going to do a dictionary attack, they've got to go through the 64,000 iterations for every time they're trying it, and that adds enough overhead that users aren't going to really notice, but is going to really slow down the ability of somebody to crack that password. Or if they want to bypass that, now we've got a key space that's a mile long, and that because it's this hashed value that's something on the order of 64 hex digits, and that that's going to massively inflate the number of things that they're going to have to try, and so it's trying to help save on the brute force attacks. There is a related project, IO Cypher, that offers a virtual file system that's using SQL Cypher under the covers as the backing store. Rather than actually storing files on the file system, it is storing blobs in a column in a SQL Cypher table. And so therefore you get all of the same encryption capabilities of SQL Cypher. You can even share the passphrase, and that because you can share the SQL Cypher instance. And just as we replace SQLite database and SQLite Open Helper with equivalents, in this case you replace file with an IO Cypher equivalent, and you work with its implementation of file, which is going to turn around and do the actual SQL IO with all of the encryption and decryption along the way. And so this gives you the feel of a file, working with the input streams and output streams and so forth, and that yet the results are all encrypted, and once again, with sensible defaults for encryption algorithm, key derivation, initialization vectors, and all that icky crypto stuff, that if you were going straight to Java X Crypto or Bouncy Castle or something like that, you got to decide all of that stuff yourself, and too many developers make the wrong decision. As I mentioned, do not hardcode passwords, even if book examples do so. And that the WhatsApp was disclosed within the past month or so, and that hard-coded the passwords for their encrypted data. And therefore, you could actually get that password through fairly simple reverse engineering, and as a result, you wound up where all that stuff could get decrypted. There's another possibility of rather the hard coding the passphrase is to say, we're going to save the passphrase on internal storage. That too offers limited security. If they can root the device, they can get at that file. Facebook released the Facebook Conceal open source library within the past couple of months. And that it got a lot of pub, and that the Facebook trying to help security on Android, and it does to a very limited extent. The net effect is that what they're using it for is for external storage, and that the stuff that users and the other apps can get to, they're encrypting it on the fly, much like how SQL Cypher encrypts on the fly with sensible defaults, but storing the encryption key that they generate and then on internal storage. So the net effect is that external storage winds up having the same security characteristics as internal storage. and that it would be easier for somebody to root the device and get at internal storage than it would be for them to brute force the external storage encrypted files. But that still limits you to the security of internal storage, which may or may not be deemed adequate for your application. Android allowed backup flags that you can have on your application element in your manifest. If that's set to true, then anybody can download your app's data. And then if they have the Android SDK and sophisticated data transfer tools, such as a USB cable, and that they just run a command and boom, they're going to get a backup of that data, and that backup and that can easily be picked apart and get at your data. If your data is encrypted, SQL cipher or whatever, and that's less of an issue. But if you are simply relying on internal storage, and that bear in mind that if you're allowing these backups, that's a significant hole in your security defenses. And that you may be better served implementing your own online backup regimen, and that frankly, I don't care for Backup Manager that much. I've got a blog post from 2010, 2011, whenever they released it, and that unsafe at any speed, pointing out that there's absolutely no guarantees anywhere with the Backup Manager system of where that data is going. And that, I mean, they specifically disavow in all of their literature saying where the data goes. It does not have to go to Google, and that it could be backed up at a carrier, and that it could be backed up by people who you don't care for. And of course, don't create world-readable files. There's reasons why that stuff's not deprecated, and that don't be using mode world-readable, mode world-writable, and that is you're creating files on internal storage. Surprisingly enough, world-readable files are world-readable, and that anybody can go get to those files. And that if you want to make data on internal storage available to third parties on a selective basis, use File Provider. It's available in the Android support package as of last summer, and that it's a drop-in content provider. No Java coding required. All you do is plug it into your manifest, give it your authority string and whatnot, have a little bit of XML metadata to say, okay, kind of like how you configure a web server. If you see a URI that looks like this, that's referring to this location on internal storage, and then File Provider actually will serve up the files for you. And that way, you've got Android permission mechanisms and whatnot, and that we're helping to limit who's going to be able to get at that stuff, as opposed to it being the world.
Mark.
Yep.
So this data encryption will work if I have to expose some data to the services, like contacts, for example. It's going to be unencrypted at that point in all likelihood. And I mean, there's nothing stopping you, I suppose, from using one of those random extra values on contacts contract and that for storing some encrypted bit. But that's not the norm, and that usually you're putting stuff in there that's supposed to be publicly visible. And therefore it will be unencrypted and it will be publicly visible. And that we'll get into some of those sorts of issues, and that if you do elect to expose data from your application, and that do so consciously, and that we'll talk about some unconscious or maybe semi-conscious ones, and that coming up here in a bit. So in theory, I should have two sets of data. One is publicly available data, and one is personal kind of data, basically.
I mean, if that makes sense for your app, yes. And that you can use I haven't dealt with contract in a while now, but there's the way of getting the somewhat durable identifier of the contact, and that use that as the key for your own database, and that additional data, and that you want to associate with that contact, but you want to control it, you want to keep it away from contacts contract, because anybody with the read contacts permission can get at anything that's in contacts contract. Another approach to the encryption is to say, yeah, all right, I don't feel like dealing with all that stuff. We're just going to make sure that the user has done full disk encryption on their device. And then, full disk encryption's been around for a while, and is actually not that bad nowadays, other than that teensy little problem that Google still insists that the password for the full disk encryption has to be the same password that you use for getting past your lock screen. People get past their lock screen all the time, and so therefore they tend to choose relatively short pins, which means that that full disk encryption can be brute forced. That being said, it's
enforcing full disk encryption is better than nothing. And that and of course, that is also, of course, going to be subject to your $5 wrench attacks, and that you can't have a security presentation in the modern era, and that without having an XKCD slide of at least one. And I actually have not done the conversion rate. I forget exactly how much $5 is. I mean, $5 is pounds. But it is possible for you to go in and say, okay, I want to use the device administration APIs to say, yeah, I want you to do full disk encryption. Now, what I'm going to show is a little bit of device admin stuff for password quality, and that it's a short jump from there to be able to go in and set things up to require full disk encryption. You wind up having a device admin receiver. That's a base class that you'll inherit from, that you will use for handling various events. You'll put that inside your manifest somewhere, where that is defended by a system permission, bind device admin. Only the firmware can hold that permission, and so only the firmware is going to be able to talk to this particular broadcast receiver. Talk more about that concept in a bit. Where I in particular am looking to find out, hey, when are passwords changed and when are passwords successful or failure? And in particular, I want to log password failures, and because I may want to do that as well as enforcing full disk encryption, so that I've got some idea that somebody maybe has taken. Last year there was a project where they took an Arduino kit and that hooked it up to a robot with a capacitive stylus who basically would brute force at the lock screen level an Android device. It had a camera that basically was looking for detection, okay, did we get past the lock screen? And I think they used a Raspberry Pi, and that as the brains behind the operation. And so this little robot would try all sorts of different pin combinations until they came up with one that worked. That of course will result in a lot of password failures, and that you could, with the device admin APIs, you can find out about those and take appropriate steps. If they failed 10 times, we're going to alert IT security. If they failed 20 times, we're going to remote wipe the device. Stuff along those lines. You wind up also needing a little bit of metadata specifically to tell Android, okay, what capabilities of the device admin API am I looking to use? This particular app is looking to control the password quality. We need you to have, a minimum of 10 characters, and at least 2 of them have to be, numbers. And we're going to watch for login failures. There is also storage encryption as an available option to say I want to be able to require that the device has full disk encryption. Device admin APIs is something that the user has to opt into. And so you can get a device policy manager. It's one of those ever so fun system services. And ask the manager, hey, am I a device admin? Am I active as an administrator? Where you pass in a component name that points to that device admin receiver implementation that you have in the manifest. This simply returns true or false of whether or not the user has agreed to have your app be a device administrator. If it's false, you're going to be able to go in and fire up an activity to prompt the user, hey, could you please make me a device admin? And maybe your app refuses to run until they do so. If you are a device admin, well then you're going to be able to go in and, determine whether or not the active password, meets, your requirements and so forth. Where you can set those requirements up via methods like set password quality, and that in your device admin receiver. Similarly, there is methods where you can require full disk encryption to be on. What you can't do is force the full disk encryption to happen immediately, because it may not be an appropriate time for the user to spend the hour or whatever it's going to take to run through the full disk crypto process. In particular, you really want to be plugged into in the mains at that point in time, and therefore, they may not be in position
do that. So you can ask that it be full disk encrypted, you can find out if it's full disk encrypted, and that you cannot force it to be full disk encrypted, and that immediately, because that is a very lengthy operation. But you can use these sorts of things in order to help make sure that the environment in which your app is running is secure enough using framework, platform level security. You gotta watch out for the things where you are exposing data that you weren't thinking that you were exposing data. One big thing comes with exporting your components. An exported component, or by component I mean activity service, broadcast receiver, or content provider, if it is exported, third-party apps can talk to it. The rules. Activity services and manifest registered broadcast receivers are exported if you have an intent filter. If you do not have an intent filter, they are not exported by default. Though there are ways with the Android exported flag in the manifest that you can override that behavior. If you are registering a broadcast receiver through the register receiver method, it is always exported because you're always providing an intent filter with those. Those cannot be used with explicit intents. They always have to be an implicit intent. Content providers, up through Android 4.1, were exported by default. This was dumb. I have no idea who thought that was a good idea. There's a million apps out on the Play Store, and that I got 20 quid that says that there are at least 10,000 apps out there where the developer, wrote it a couple of years ago before Link started warning you, hey, your content provider's exported. You sure about that? And then where they thought that content provider was just purely for internal use, and their data's flapping in the breeze because they have no protection on that content provider at all. Anybody can go in and read and write that data. Dumb! Now, Lint has been kvetching about this for a while, and so apps that have been maintained, if the developer is paying at least a little bit of attention, and then they'll hopefully lock that down. And as of Android 4.2, the default of a content provider is that it's not exported. Which is why you really want to have the Android exported flag on your content providers to explicitly say what you're looking for, because if you accept the default, it's going to vary depending upon what version of Android you're running on. Exception being if you're only supporting Android 4.2 and higher, and that you could, perhaps get away with, assuming that it's not exported by default. The net effectiveness. Only use an intent filter if you're really trying to talk to third-party apps. Don't have an intent filter for purely internal purposes. We see this a lot out on Stack Overflow, and they show their manifest and they've got these intent filters, and that with custom action strings, and it's pretty obvious from the circumstances that they're not really expecting third parties to talk to those activities and such. But they're just kind of blindly copying things around. They saw the intent filter for the main launcher, combination, and that for the home screen launcher, and assumes you needed to have an intent filter everywhere. So your launcher activity, it needs an intent filter, because we're expecting third parties, like the home screen, to talk to it, to start that activity. But don't say that every one of your activities has an intent filter. Specifically, don't go in and say all my activities have an intent filter, but I'm going to have them be not exported. There's what I would consider a bug, and what Diane Warren considers to be just the state of the world, and that where things like the chooser, when you get the chooser window, when you start up an implicit intent for an activity and there's multiple possible matches, and that doesn't actually filter upon whether or not the user can actually do any of the things that's in there. And so if you've got an activity, let's say, for example, your United Parcel Service, UPS, and a package delivery service, and you maybe, for example, published an app that allows people to be able to work with UPS, and maybe that app you ripped code out of barcode scanner and incorporated it into your app so that you could scan barcodes without depending upon the zebra crossing barcode scanner app. And you just blindly copied the manifest entries, and so you're advertising that, oh yes, we support com.zxzing.intent.action.scan. Oh, but we don't want to do that, so we're going to mark it as not exported. Well, now
if somebody, launches an intent, starts an activity with that action, say another app is really using Intent Integrator to talk to Barcode Scanner, now they get two choices, Barcode Scanner and the UPS app. They tap on the UPS app and boom, crashes with a security exception. And then, so if you're going to have an intent filter, please have the component be exported because you're trying to talk to third parties. If it's purely internal, ditch the intent filter. Just use explicit intents. Just bear in mind, nothing's stopping you from attaching an action to an explicit intent. So if you've got code in your app that is looking at action strings and is branching based upon that, you can still do that without the intent filter, so long as when you're creating those intents, you just stick the class or the component name inside the constructor. Again, pay attention to your content providers, and then if you do export it, please secure it with permissions. We'll talk about that in a moment. Register receiver. Try to minimize your use of this for purely internal communications within your app. And then use an event bus, local broadcast manager, Square's Auto, Green Robots event bus, something along those lines. Those are purely within your process. They don't leave. And that register receiver is open to the world. There's ways you can secure it with permissions, but it is exported by default. And so now you're in circumstances where third parties could craft a broadcast that they send that you wind up picking up that maybe is spoofing data, maybe is trying to crash your app, things along those lines. And beware of all those other control channels that you are setting up to allow your app to be controlled from outside. You rigged up the stuff where you're watching incoming SMS messages and that for like a password reset mechanism. Guess what? Anybody can send an SMS message. And then how do you know that those SMS messages are triggered by, say, your website through some SMS gateway and that versus somebody else who's trying to break into a user's app or, otherwise mess up, the functionality of that app, denial of service sort of thing. They reset some user's password, and that does something they don't know. If you have a server socket, and that you're really open, at minimum, you're open to anything on the device if you're listening to localhost, and heaven forbid if you're listening to, the real IP address of the device on Wi-Fi or whatever, now you're open to other things that can find out that IP address and talk to you, even if that IP address, is behind NAT or whatever, and that there's still going to be more devices than that are going to be able to talk to you. And many of those things aren't what you want to talk to you. And so on, and that make sure that you understand what is going on. GCM, while spoofing is less of an issue, bear in mind that while Google encrypts that data in motion between your server and Google, and between Google and the device, Google's got this data. And even if you trust Google, Google has let's just say the NSA that has apparently done some interesting things with Google, and so you may want to consider, do we need to encrypt and that those GCM messages, and to at least reduce the odds and that of somebody peering at that 4K worth of data, or do we need to make sure that that data doesn't contain anything directly of value? It's simply like a URL or something to trigger a poll. Where we've got our own security for handling the balance. If you are retrieving data that is protected by system permissions and you in turn are publishing that data through your own API, please turn around and secure your APIs with permissions themselves. Otherwise, you're going to wind up leaking data. You go get contact information. You make some of that contact information available through, say, a bound service or your own content provider or something like that. Somebody figures that out. Now they can go get at contact information by talking to your app, even though they don't have read contacts. They don't have access to maybe everything of the contacts data, but they'll have access to whatever you're publishing. You should be defending your API either with your own custom permission or, if nothing else, with the same read contacts permission. So that way, that third party app who's talking to you the user has got to know that, hey, that particular app is trying to access this data, and so they are aware of what's going on. Your activities, services, broadcast receivers, you can have the Android permission attribute on them, automatically defends those components with that permission. Content providers, you also have read and write permission as separate things or controlling read and write operations, similar to contacts, where they basically have a read permission of read contacts and a write permission of write contacts. If you've got scenarios that are more complicated than that, you can always drop down to use methods like check calling permission, methods on package manager and so forth in order to be able to determine, is my caller, does it have, a certain permission? Does this package over here that is looking to talk to me, does it hold a permission to introspect these sorts of permissions at runtime to see who holds what? You can take that another step further and invent your own permissions. You can have permission elements in your manifest, and that where you give the permission a name, please don't use the Android permission prefix on it, and that you want to make sure that your permissions aren't going to collide with anyone else, let alone ones that Google comes up with in the future. Namespace it for your own project, please. Reverse domain name, same sort of thing you'd use for your packages. You provide a label and a description, which is going to control what the user sees at install time, and that along with any other permissions that the third party is asking for, they're going to see your label and your permission. So make these string resources, translate them for everything that your app is translated to, and remember that you're talking to users here. Speak human, and that don't speak geek, and that they may not understand geek, and you can specify the protection level, where the 3 that we SDK developers will typically work with. Normal and dangerous, any third-party app can request to hold those with the corresponding uses permission element. The only difference between those is where they appear in the sort order, and that dangerous ones will tend to appear higher in the list of requested permissions. In particular, in cases where some of those permissions, there's like a see more sort of fold-out area, dangerous ones are always above the fold. Signature says that only an app that is signed with your signing key can hold this custom permission, in theory. And so therefore, that's designed for cases where, say, you've got a family of apps, and you want them to be able to interoperate, but you're not necessarily trying to open up these APIs to arbitrary third parties. You're going to have all your apps signed by the same signing key. They'll be able to talk to each other because they'll be able to hold the custom permission and therefore talk to components defended with that permission, even though they're not going to, third parties aren't going to be able to hold it, in theory. The problem is that this doesn't work. Specifically, permissions are first one in wins. Anybody can define a permission with any name. And as a result, if somebody else gets into the device before your app does and defines your permission, they can define it however they want. They can change the protection level, they can change the labels, and that to make it seem more benign than maybe it really is. And they can hold it without the user knowing about it. If you define a permission, you can hold that permission without the user being prompted about that permission. And so therefore, they can hold a permission of yours, even though the user should have been informed about it simply because they were installed first. This sucks. So, walk through some quick scenarios. And we've got 3 applications. App A is your app. You've defined a custom permission. You're defending components with that permission. App B is an attacker. It wants to be able to talk to App A, talk to those secured components without the user knowing about it, and bypassing any signature level restrictions. Whereas App C is maybe a more ordinary third-party app. And that maybe you're publishing details about your permission because this is actually part of an API, an SDK that you're exposing, and that App C is a more legitimate user of that API. In the normal case, your app is installed first. And then, say, App C gets installed. At that point in time,
When app C is installed, it will see the user's permission element, the user will be prompted, hey, app C wants to be able to do X, Y, Z, and the user can say yep or nope as the user sees fit. But if C is installed first, the user isn't told about this custom permission that was requested because it's at the time of C being installed, that permission wasn't defined yet. The user's permission said, I'm looking for a permission named foo. Android looks around and says, I don't know what foo is. I don't have a label or a description for it. So the user isn't prompted about it, because there's nothing to prompt them with, but C doesn't actually hold the permission. And so when C tries talking to app A, C fails with a security exception. In some cases, this isn't a big problem. In a case where app A would almost assuredly be installed before app C, this isn't a big deal. So if this is a host and plugin scenario, the host app is almost always installed before the plugin. And then if somebody installs the plugin first and therefore has to uninstall that, install the host app, and then reinstall the plugin, it's not the end of the world. But if these apps are more peers, Facebook wants to talk to Twitter, or Twitter wants to talk to Facebook, they could be installed in either order, and that there is no assumed cardinality there, assuming you don't work for Facebook or Twitter. And therefore, maybe those are protected by custom permissions, and that you run into a problem. But you could say then, okay, well what we have is that we'll have third parties actually define the permission themselves. We'll have a third party app also have the permission element in it. That basically is what app B is doing. App B is going to define the same permission that app A does. If app A is installed first, life's good. App B is going to behave just like app C did. The user will be prompted about this custom permission, and the user can make a theoretically informed decision. But if app B is installed first, because app B also defined this custom permission, app B gets that permission without the user being prompted. And app B can define that permission however they want. And so your app wants it to be a signature level permission, they define it to be normal. And so even though they're not signed with the same signing key as your app, they'll be able to talk to your component. The good news is, because installation order is key here, it is relatively unlikely that this is going to be a problem for a bulk attack. Malware could certainly be uploaded to the Play Store that exploits this, but it's a 50-50 shot, of whether or not they're going to be installed first. And if enough installs of this malware app that claims to have this permission and users decline installing it, maybe somewhere along the line somebody's going to realize that something's going on here. But if the app B, the attacker, is in a situation where it's known that it can be pre-installed first, now we have more of an issue. Devices being handed from employers to employees. Buy a used device off of eBay or Craigslist. The gift bags they give out at the Oscars. And that you gotta have a smartphone in those nowadays. And then any of those sorts of scenarios, and that there could be preloads on them. It could even be that it's preloaded with a ROM mod that you buy a device off of eBay specifically because they've installed CyanogenMod on it, because you don't want to go through all the headache of installing CyanogenMod. You don't know whether or not that is CyanogenMod. It could be a mod of CyanogenMod that has app B's in there where they're going to go in and they claim to hold Facebook and whatever permission. I've got some help for this as well. In that Quack security library, I have permission utils with a check custom permissions method. You just call this method, you supply your context, and then I will turn around and I'm going to scan first your app to figure out what custom permissions you define. And then I'm going to scan all the other apps in the system to see if they also define those same permissions. The idea is that you call this on first run of your app. And so I will go through and I'll quick check to see whether or not anyone else has already defined one of your permissions, give you back the details. So, okay, well this permission is being held by this application, and in particular I'll also tell you whether or not there's changes. Did they change the protection level? Did they change the label or the description? Because it may be there are cases where you do want third parties to actually define your permissions for you, so that the installation order does not matter, but you're relying on the fact that that permission is defined the same way that you would have defined it, and that I will help you determine that. And so you can use this check custom permissions in order to be able to then make decisions. If it comes back and there's nothing, then life is good. You were installed first, your definition of the permission holds. If somebody else was installed first, and that their permission is the one that's defining matters, you can know about it, alert the user, send it back through your analytics channels, refuse to run your app, whatever level of defense you believe is appropriate for that circumstance.
Can my app override, like say for example, if the first application B has a normal permission level, can I override it to say it's more secure with signature or something like that?
Nope. Again, first one in wins. It would be, and that the problem with that scenario would be denial of service. Now an app B who would be installed afterwards could upgrade the security to signature level, and now all the stuff where you're expecting to be able to talk with that permission won't be able to talk if they're not having to be signed by the same signing key. And so ordinary SDK sorts of stuff where you're providing an SDK for third parties, now all of a sudden those break, so the host can't talk to its plugins and things like that anymore. So that doesn't work either. It's first one in wins, period. But you can detect, if something was installed before you and they defined it as normal, you defined it as signature, this will tell you that that has occurred. And you can take steps. What you can't do is basically somehow convince Android, no, please change the definition of this permission to be signature.
Is there anything like on the fly I can create my own separate names or something like that? No?
No. And that it's got to be baked into your manifest. And so in terms of what you're publishing, and that it's got to be a fixed value, and that for you and for all the apps who are trying to work collectively with this permission. Sometimes you're going to want to have these permissions, but for not everything. You want to have pinholes in the permission firewall. For example, a content provider, if it is exported says third parties can talk to this content provider whenever the third party wants to, and then it's up to your permissions to defend against them. And then, even if it's not exported though, third parties can still talk to that content provider when you say they can. You can say, oh, okay, hey, I've created this email client. I want to be able to view an attachment. It happens to be a PDF. Well, my email client doesn't have a PDF library baked in. I want to launch the user's choice of PDF viewer. But I don't want all apps on the system to be able to get at the user's email attachments all the time. I don't even want the PDF viewer to be able to get to an email attachment at arbitrary points in time. I want to say, right now, I want to start an activity to view this PDF, and you can view this PDF at this moment, and then your access is going to lapse after some period of time. To do that on your provider, and that you can have the grant URI permissions attribute. If this is missing, you're saying, I'm not trying to do per request customization of the security. It is what it is in terms of the exported flag and in terms of the permissions that I have on the component. If this is set to true, then your Java code is allowed to have any of your content that's published by this content provider be readable on a per request basis by including on the intent that you use, say with start activity for the action view for the PDF file, including flag grant read URI permission and or flag grant write URI permission, which says for this particular request and nothing else, whoever's processing this request gets to hold my read or write permission for this content provider. And that their ability to do so is gated by whatever URI is inside that intent. That they can get to this one URI for this one operation for this particular capability, but nothing else. Grant URI permissions equal false says Yes, I want to have this capability. No, I don't want it to be for everything in the content provider. Instead, Android will look for a grant URI permission child element where you will list a little bit along the lines of how you provide URIs in your intent filter with the data elements, and that to say, okay, these particular paths inside of my content provider, we can use that for these for these flags, but other paths are not considered valid. So for example, I'm going to expose the email attachments, but I also have my content provider exposing the emails themselves. Will allow flag grant read URI permission to work for the attachments, but not for the emails. You gotta hold the permission for those, and that way, even if some future developer accidentally tries putting these flags on the intent, they won't take effect because they won't be matching one of the URI paths and that you've specified in the grant URI permissions element. And so this way, you can say, all right, I'm going to lock down my provider, yet still allow third-party access, even without user having to, agree to permissions or anything like that, but on a very selective basis, small pinholes in that file. Sanitize your inputs. And that, we're used to thinking things of like on a web app and that, little Bobby tables scenarios and that where, somebody types in SQL into one of our input forms and that in hopes of, modifying our data, crashing our backend, whatever. And that there are similar sorts of things you're going to want to consider and that in your application. If you have exported components and you're accepting extras on those intents, make sure that the extras make sense. Google screwed this up. It was a vulnerability that was announced several months ago, and that even though the underlying fix had come out a little bit before then, if you've implemented a preference activity recently, you'll know that you've got to override this isValidFragment method, and that to say, hey, is this fragment supposed to be shown in this activity? On the surface, that looks totally goofy. It's like, why are you asking me this? I'm the one who's setting up this activity. The problem is that preference activity accepts extras that allow outsiders, whoever is invoking that intent, to specifically say, I want to drive to a particular preference fragment, rather than maybe showing, say, the two-frame tablet layout and that at its initial starting point, we want to specifically go to a particular preference fragment, and so we'll activate that one in the list and we'll show that one on the right. And they didn't actually check to make sure that that was a fragment that was supposed to go into preferences. And so any fragment could be specified. And so therefore, you would have circumstances where an attacker would be able to cause an arbitrary fragment out of your application to appear to the user, and that even though that, it may be that that's not an appropriate point in time. For example, maybe it's the sort of thing that fragment is only going to be shown to logged in users, and now they can arrange to show it when you're not logged in. And so there they were inspecting, they were accepting an extra, they weren't sanitizing it to make sure that it was valid. They then added that into the API, leaving us to have to do the validation for them. The URIs that you get in on the intents, if there are certain characteristics that you're expecting that aren't going to be automatically handled by your intent filter, and that you might want to examine those. And bear in mind that, there's, the URI could actually be pointing to anything. Have defensive programming and how you would interpret those URIs in terms of, the input streams you get back or whatever, and that with the content resolver that you are not going to make mistakes with that data if they hand you something that claims to be a PNG but isn't. Content provider or other places where you're using SQL, yeah, SQL injection could be an issue. Less though of a problem for users. Users aren't likely to be typing in little Bobby tables into your GUI, and that's simply because it's only going to affect them. It's a bigger problem if you're accepting data from outside, RSS feeds, and that stuff like that. Could there be something that especially crafted RSS entry, and that the description happens to contain stuff that's going to effectively be a SQL injection attack against your application? If you're exposing a bound service via IDL to third parties,
same stuff that you'd ordinarily do with an SDK, and that check your input parameters, make sure that they're sensible. Think a little bit about your development tools. Gradle is going to be a big thing here in 2014, and that we're making the pivot from Eclipse and Ant to Android Studio and Gradle. And Google and Gradleware and whatnot say Gradle W is a great solution. You use Gradle W as your command to run your Gradle commands, and it will bootstrap your environment. If you don't have Gradle installed, or you have a different version of Gradle than the project's expecting, we're going to go in and we're going to download this. Only use Gradle W if you are trusting implicitly that project and where it's getting its tools from. This is designed for enterprise circumstances, or work other teams, and that where you've got a bunch of developers and that you're working with an internal repository, that sort of stuff. I don't publish Gradle W on any of my Quack libraries, even though they're all Gradle ready. And that because you shouldn't be trusting me to be providing you with your copy of Gradle. You've got no idea where I may have tweaked the Gradle W configuration to pull stuff from, and that I could have gone in there and be having you download some hacked version of Gradle W, or I'm going to happily copy up to the internet all your source code, and then even for your own private in-house apps. Don't use Gradle W unless you trust it implicitly, and I should not be trusted. Similar, you can wind up with similar sorts of things for your build time dependencies, and that effectively those are extensions to Gradle, and that, yeah, we are hoping that, nobody hacks Maven Central, and that I'm waiting, and that it seems inevitable, and so just keep in mind that, the more you are doing download tools on the fly from arbitrary stuff that you aren't doing the downloading yourself, you are trusting that those downloads are downloading what you think they're downloading and not downloading something else. Similarly, you need to think about sanitizing your outputs. Some things that we do in Android development implicitly provide data to third parties that we don't necessarily think about that way. Anytime you're creating a remote views, the whole point behind the remote views is to pass it across process boundaries for some third-party process to render your UI, such as a home screen rendering your app widget. Well, that home screen can look at those views, because it's their views once they, render them onto their own UI, so they can look at any of the data inside of there. Do not publish private information via remote views. Do not publish private data in a notification. Notifications can be read by apps that, implement notification listener services and so forth. Clipboard. Any app can go in and read the clipboard. And so on the one hand, the password manager that puts the password automatically for you on the clipboard for easy copy and paste, oh, that's so slick. On the other hand, for that window of time, that password is available to anyone. And, malware could look and say, hey, gee, KeyPass X KeyPass Droid happens to be in the foreground at the moment. Maybe I'll pay attention to what's going on the clipboard. And then be real careful about what you're putting on the clipboard if you know that it's something secure, and that to, if nothing else, try to get rid of it from the clipboard after a reasonable period of time. Intent extras, there was a bug that's since been closed, and that where any extras on activities that wound up basically being the latest on the task entries and that, and so it would show up in places like the running task list. Any app could get to those extras, and that particular problem's been fixed in newer versions of Android, though it still exists in older versions of Android, and who knows what other similar bugs may be lurking around. Be a little bit careful about what you're passing around in extras. Wearables, we're going to be starting to get into, hey, let's push UIs up to the wearable. That's going to be similar sorts of problems with the remote views, and that where, now our notifications and remote views and whatnot and that are effectively going over the air, and that is not going to pose any particular problem since we're not responsible for that security. We as a community over time are going to need to be building up more and more stuff. We can't assume that Google's necessarily going to help us lock everything down. Google's interests and that may not necessarily line up with ours, and Beyond that, Google's only got so many people and they're working on Android. We like to think that they've got this vast army, but I distinctly remember a time when the tools team and that was seriously outnumbered by the contents of this room. Even today, it is probably outnumbered by the contents of this room. So we need more frameworks, more tools to help developers understand what's going on. One thing that I'm kind of interested in poking at is mutation testing for permissions. Don't request permissions you don't need. Not only do you not need them, and therefore it's just going to provide comfort to the user, but it's conceivable that that could wind up offering up some sort of an exploit. For example, a manufacturer who shall remain nameless in part because I forget, and that had their device hacked from the phone to own, and that contest, and that because they had a system installed app that requested the install packages permission. That was a firmware installed app. It could hold that permission. It could download and install apps without any user involvement. The problem is that app didn't need that permission, and it had bugs that then they were able to exploit those bugs to get the app to download other stuff that could then turn around and do whatever the attacker wanted. Mutation testing, and there's another session on mutation testing in general here at the conference, and that is basically saying, if I have a test suite and I have an app, if I change the app, let's say change +1 to -1 in a calculation somewhere, my test suite darn well better fail. And if it didn't fail, then my test suite isn't complete. It didn't have a test case that covered that particular change. Same thing with permissions. I should be able to go in and selectively remove permissions, and my test suite should fail. And that if it does not fail, then either A, my test suite is incomplete, or B, I didn't need that permission in the first place, and therefore shouldn't be having it in my manifest anyway. Overall, I'm a big fan of open protocols, federated environments, and that fewer data silos, and that because those silos, if they become popular for both good and bad. And that ideally we come up with more standards. Users are starting to clue into the whole little lock icon thing in their web browser indicating security. What is the lock icon for a mobile app? Is there an equivalent? What should it be? What should it mean? How can we let users know about the security level of what's going on in here? Now, at this point in the presentation, convention says that I should say something like one more thing. Given the title of my presentation and where I'm delivering this at, I can do something else, and that this presentation goes to 11. One thing to watch out for is when you're talking to a third-party app, is the third-party app the app you think it is? We're going to implement an app that holds on to encrypted documents. We're going to hold those on internal storage. We're going to put them in IO cipher or something. We're going to defend it with our lives. We aren't going to try to implement a PDF viewer. We're going to allow a third-party PDF viewer to actually render the PDF. Well, if it got access to the PDF, that third-party app could do anything we want. So, since this is an enterprise app, we're going to limit the communications. We're going to say there's only this particular vetted set of PDF readers that we're going to support. We're not going to allow the user to view this PDF in anything else. The problem is that your only way of controlling that is by package name. I'll only talk to com.adobe.reader or something like that. There may well be a package installed on the device whose package name is com.adobe.reader. Is that Adobe Reader? Is that a modified version of Adobe Reader that will do things that the user or the enterprise will not want? Does it have nothing to do with Adobe Reader and that it is a total piece of malware? It could be any of them. There's ways that you can detect these things, though. As you're aware, all of our apps are digitally signed, either by the debug signing key or when you're shipping in production by a production signing key. We can get at that information at runtime via package manager. And so therefore we can check signatures. Another thing I've added to that Quack security library is a signature utils class, where I've got a check get signature hash method. You provide me a context and a package name, and I will give you back an SHA-256 hashed version of the signing key that was used to sign that app. You can then compare that against, say, a pinned value inside of your app in order to say, oh, okay, well, I am expecting that the signing key for com.adobe.reader should look like X. Where you get that hash, if it's, say, for your own internal stuff, Key Tool can give you that hash. And then if it's from a third-party app, you basically, whoever the security team is that's vetting that Adobe Reader isn't going to do anything nasty with your document, can also basically have a little utility that uses the same method to dump that hash that you can then turn around and embed in your app. Or maybe you do the memorization sort of approach, trust on first use. You assume that Adobe Reader is fine, but if at some future point in time that you on that same device you talk to an Adobe Reader and the signature changed, well, maybe somebody got into that device and replaced Adobe Reader with a modified version, and therefore wound up with a different signature. That in turn is good. You can take it a step further if you want. You can hash the whole APK file. You may have heard of the master key vulnerability. That too, I believe, remember that was last year. And that the master key vulnerability boils down to that the zip logic used to create the APK file and the zip logic used to read it were different implementations. And there were scenarios in which you could zip things that would be ignored in some circumstances and paid attention to in others that could cause you problems. The signing would basically be ignoring any of that extra stuff. And the signing does not cover everything inside of the APK file, like the meta.inf folder is not part of the signature. So you could take it the next step and say, all right, I'm going to hash the whole APK file and compare that against known values. The downside of this is that that's going to change frequently every time there's a new version of that partner app, and that the APK is going to line up with a different hash. So you're going to need to have some way of dealing with that. The signature is going to be more stable, and that there are corner cases in that where the signature may be insufficient. So, these sorts of things are stuff that are within reach. None of this stuff requires you to be a crypto expert. None of this stuff requires you to be a security expert. I'm not a security expert. I don't play a security expert on TV. They're the sorts of things that you can do, you can integrate into your process, and then in order to try to lock down your app to make sure that your users are defended against those forces of evil. Questions? I stunned you into silence. Either that or you're short on caffeine. Okay. We're going into another coffee break, down back on the first floor, and that before heading into the next round of sessions. And then thank you all for attending.
Is that the same code as yesterday?
QR code, I hope. There should be a new QR. It will lead you to speaker deck again, but these QR codes are to the presentation, not just to my general speaker deck.
Yeah, quick question.
Sure.
If a organization, so for example, Adobe Reader, they got two products. One is full reader and one is light mode, for example. Right? They come up with two, for some reason, they come up with two keys, APK keys, right? Or when they deploy it, they have two public keys basically for some reason.
Okay.
Right? So the security manager or application manager basically will read to that application key and find out whether it's a genuine key or not, something like that, right? If I have to find out whether it's a genuine application or not.
Sure.
But then if I install both applications, right, and for some reason their description or name says Adobe Reader, for example, Adobe Reader, right, being named saying which application will get access to it. Means if I read application key, it will give me one application key, but
if two apps define the same permission with different labels, first one in wins. And so if, say that, Adobe Reader and maybe some other Adobe product, and that both define the same permission, that description should be a generic Adobe description, and that if the description says, something particular to say Adobe Reader, and then the user later goes in and installs a different Adobe app that's also requesting that permission, they're going to be prompted with the description for the Adobe Reader one, and that because that was installed first, and that may cause some confusion. And so if you are going to create custom permissions, in addition to the vulnerability stuff that I talked about, you're also going to need to think about scope and what the appropriate language is. And that if this permission is unique to this app, feel free to use language that's unique to that app. If that permission is going to be something that's going to be more generic, use language that's going to be more generic. What I haven't experimented with is changing that language. Let's say Adobe Reader, and that we ship with Adobe Reader specific terminology. Then the decision is made, no, wait, we're going to use this permission across the whole Adobe suite. Can an update to Adobe Reader change the description of the permission in such a way that it will affect those later installs? I haven't tried that, and so I would hope that's possible, but I can't guarantee it. And I have no idea whether that data is effectively copied at install time into a separate spot inside of the system and is not refreshed when that application gets updated.
Right, thanks.
Sure.
Could I ask you to plug your book really quickly?
Sure. The Busy Coder's Guide to Android Development, 2,600 plus pulse pounding pages. Though if your pulse actually pounds when reading a technical guide, please seek medical help.
I know this is going to be really hard for you, but can you say that again slowly?
Exactly.
The Busy Coder's Guide to Android Development.
Thank you.
And more importantly, go to commonsware.com. I sell this on a subscription basis. You will not find this in stores. But it's updated several times a year. And that the Warescription that gives you access to this gives you access to other stuff, office hours chats, discounts on webinars, Stack Overflow bump service if your question is lingering and you're not getting the answers you need, and so forth, and that for $45 US per year.
How's it delivered?
PDF, EPUB, MOBI, and an APK file that you can install directly. Mainly because A, EPUB readers for Android suck, and I wanted to prove that you could actually create an ebook reader that will honor the author's CSS and that without mangling it. It also has grateful text search. I've integrated SQLite FTS 3 or 4, I forget which, and that into there, and so lightning fast search for terms. And as you type in a class name, and then bam, all the references to that, and then are going to appear in a flash.
That sounds good. $45 a year.
Yep.
Cheers.
Any thoughts on variables, Android variables? Like what's trends or what's going to happen with them kind of in future?
Oh, wearables.
Yeah.
Well, obviously Android Wear, and that has been kind of the bomb that's been dropped into the space recently, and that hadn't been other than we knew that Adobe acquired Win Labs and therefore was probably going to do something beyond glass, and that that wasn't widely expected, and so once Wear devices become available, and that'll be I'm going to dive into those more, and that the wearables in general, it's more so even than pure regular Android devices, it's going to be a mixed bag. There's going to be some that'll be Wear compatible, and there's going to be some that they'll do their own thing, But of course, wearables is an unfortunate moniker because wearables run everything from your Fitbit style things where there's effectively no UI unless you count LEDs, all the way up to the Omade TrueSmart, and that which is running Android 4.2 or 4.3, and that on your wrist, and that full installation of Android, you can pop in a micro SIM card and whatnot, and then use it for a phone. And so wearables as a bucket of technology is okay. We happen to wear it on ourselves, and that is a kind of a weak connector. And that you're gonna see more focus on things that are more extended sensors and that Fitbit style and that versus, extensions of your smartphone and that ones with the displays and that designed to help surface notifications and things like that. So you're gonna see a reorganizing in that where wearables is going to be less of a concept and is going to break down, and that just because wearables is a marketing tool as much as anything else. So they gotta sell conferences somehow.
Yeah, and the wearable will be able to tell you if it has sensors if my pulse is indeed perpendicular.
Yes, exactly, yes. And that please read more slowly. And that, so.
I guess that Apple haven't released anything in that area yet. It sounds more I hear they're holding back and building in a lot of the sports integration and things like pulse detection, blood sugar,
And
goodness knows what.
And it is probably safe to assume that wearables in general and that will more substantively take off if and when Apple does enter into the space, simply because Apple still's got the cool factor, and that that whatever they come out with and that is going to look good, I did a wearables presentation at a conference getting on close to 2 years ago, and people looked at me like I was from Mars, wearables, I pointed out that we are one Justin Bieber away, and that from wearables being popular, because more so than a phone, more so than a tablet, watches and are fashion accessories in addition to functionality, and so that's why the Moto 360 hey, a smartwatch that's round and doesn't look like you've strapped a brick to your wrist. What a concept. And so it will, Apple's is going to be a sexy device both in terms of functionality and in terms of fit and finish, and we can assume that the Apple marketing engine in that is going to, again, it's going to blow the doors open on the space, which, all the Android ones and that are going to happily follow along the trail that they're blazing, and pick off, different segments and that for whatever reason aren't interested in an iWatch or whatever they wind up calling it.
And Samsung seems to be using Tizen.
Yes, they've now switched the new generation gears and that are Tizen, and that how much that is serious and how much of that is, well, we invested all of this in Tizen, we gotta use it somewhere. Oh, well, we don't necessarily need that to be an Android thing, and that who knows, from our standpoint as developers, it simply means that we can write an app, but just like the Pebble, you're not writing an Android app to run on the Pebble, you'd be writing a C app that runs on the Pebble and maybe having an Android app that talks to it. I gotta get back but also you've got the issues of, the same thing with the Samsung new gears, in that you're not writing an Android app to run on the gear, you are writing an Android app that can talk to the gear, and if you want your own custom UIs and whatnot for the gear, you are going to be having to, write the HTML5 stuff in that, and using the Tizen framework.
Yeah. Cheers anyway, sorry for keeping you.